Okay, so today we will be discussing solving and graphing two-step linear inequalities. We just finished up talking about solving two-step equations, and you guys did awesome with that. And this is kind of along the same lines. The difference is with equations, we were comparing two expressions that were equal to each other, they were equivalent. But with inequalities, we will be comparing two expressions that are not equal. They might be less than or greater than. And that kind of brings us into the symbols that we will be using. So instead of an equal sign, you might see one of these four symbols. The first one, they all kind of look like little arrows, but the first one is less than. You'll notice it does not have a line underneath. The second one looks just like it, but there's an added line, and that means that it can be less than or it can be equal to. Then the next two are greater than or equal to. So you'll notice on both of the ones that have the line underneath, it means we can also have it equal to whatever is being compared. So when it comes to solving inequalities, we solve inequalities exactly the same way as equations, except there is one difference, okay? So the one difference that we have is anytime we multiply or divide by a negative number, now keep in mind it is multiplying and dividing only. So anytime you multiply or divide by a negative number, you have to flip the inequality symbol. So what that looks like is you've got these symbols. You would go from less than to greater than if you multiply or divide by a negative. And that applies to each of those four symbols. Otherwise, it is exactly the same as equations. We want to isolate the variable using inverse operations, and we can do that by keeping both sides balanced and just going one step at a time, starting with the constant. Once you have solved, we want to be able to graph an inequality. So when we are graphing, we use either an open circle or a closed circle to represent the number. And there's a little chart here to show you which one of those we're going to use. So if you are using the symbol of greater than or less than, that means your answer has to be greater than or less than the number we are comparing to. It cannot be equal to that number, so we're going to put an open circle. So the very first thing we want to do is place a circle on the number that we're comparing the variable to. Like I just mentioned, if it is an open circle, it means it is not a solution. So for example, if you have x is less than 5, 5 would not be a solution because 5 is not less than 5. However, if you have a closed circle, that means that the answer is the number is a solution. So if you have x is less than 3, that one cannot have 3 as an answer. But if you have x is less than or equal to 3, 3 is a possible solution. So after we put our circle, we decide if it needs to be open or closed. The second thing we have to do is draw an arrow in the direction that makes the inequality true. So that'll just depend on what our statement is saying. We always want to make sure the arrow makes the statement true for the variable. So we're going to do a couple examples together before you guys get started practicing some on your own. So the first one, we have negative 4x plus 3 is less than 15. So the very first thing we want to do, just like we did with equations, is we're going to draw a line to separate our two sides. So instead of drawing the line through the equal sign this time, since there is no equal sign, we're going to draw it right down the center of that less than symbol. And then we start by trying to isolate our variable. In order to do that, we have to get rid of the constant. So the constant in this case is 3, and it is being added. So in order to cancel that, we want to use the inverse operation of addition, and that is subtraction, we know. So we will subtract 3, and whatever we do to one side, we have to make sure we do to the other. So when we subtract 3 on both sides, on the first side, it cancels those 3's because we know plus 3 minus 3, that just gives us 0. So that's going to leave us with negative 4x. And then on the other side, 15 minus 3 is 12. We don't have to do anything with that symbol right now. We're just going to bring it straight down. So we have negative 4x is less than 12. We're not finished at this point yet because the variable still has something with it. So we have a coefficient of negative 4 right now that we need to cancel out. We know a coefficient means it's being multiplied. So the inverse operation of multiplication is division. We want to divide both sides by -4. When we divide by -4, that cancels and leaves us with x by itself. And then on the other side, it gives us -3. Now you will notice we divided by a -4. So since we divided by a negative number, we have to flip that sign. So instead of being less than, it becomes greater than. So our solution to this inequality is x is greater than -3. Now, unlike the equations we were working with, which only had one solution, there are lots of different numbers that x could be to make this inequality true. So x could be 0, x could be 100, x could be -2. We have tons of options. So to show that, we want to use the graph. So we start with a number line. The very first thing we want to do is put a circle around the number that is being compared to x. So in this case, we have x is greater than -3. So we will circle -3. It needs to be an open circle because there is not a line underneath the symbol. It's not or equal to. So that tells me that -3 cannot be a solution because -3 is not greater than -3. So then our last step is just to finish it up by drawing an arrow in the direction that makes it true. So since x is greater than -3, we want to draw the arrow in the direction that shows numbers that are greater, and that would be to the right. So we draw an arrow going to the right. That shows us that all numbers to the right of -3 are included in the solution set for this inequality. So for example number 2, you guys know that with equations, and it's the same with inequalities, we don't always have the variable on the same side. So here's one where we're seeing the variable on the right-hand side to start out with. We know how to solve that. We want to try to isolate the variable. So the first thing we're going to do is draw the arrow down the center, down that symbol where we separate our two sides. We're trying to get the variable alone. So we start on the side with the variable. I see that the constant on that side is a -1. So we cancel a -1 by adding 1, and whatever we do to one side, we have to do to the other. So when we do that, the -1 and the +1 cancel each other. 7 plus 1 is 8. We bring down our symbol greater than or equal to, and then we still have n over 2 on the other side. Now we know that fractions, even though they look a little bit scary to us sometimes, they're not scary. It's just a division problem. So right now, the variable is being divided by 2. If I want to get the variable alone, I need to multiply by 2. Whatever I do to one side, I have to do to the other. So multiplying by 2 cancels over there and leaves the variable alone. And then 8 times 2 is 16. So we have 16 is greater than or equal to n. Now, what's really important on this one, we're used to seeing the variable come first, but that is not always going to be the case. So on this one, the first thing we're going to do is circle the number that we're comparing the variable to. So in this case, 16 is what we would circle. I do have the line this time for or equal to, so I will close that circle. That means just shading it in. So the first thing we want to do is circle 16 with a closed circle. And then if 16 is greater than or equal to n, don't let that sign confuse you because I want to shade what is true. I want to draw the arrow in the direction that is true for the variable. So if 16 is greater than n, that means n has to be less than 16. So we want to go to the left to show that all of our numbers have to be less than or equal to 16 to make this inequality true.